Hello and welcome. This video continues right where the last one kicked off. I said I was going to be adding add, subtract, factorial, so we're going to add some operators to our calculator. So let's go ahead and start with add and subtract. Those are binary operators in their input and they produce a single result. So 3 and 4. How would I get 3 and 4 added, or say 3 and 4 subtracted? Let's take a look at the calculator real quick. So here's an example. So let's see, 3, enter, 4 plus. Okay, great. Simple enough. 3, enter, 4 minus. Okay, notice the 4 is the second operator, or the right-hand side of the operator, and the first number entered is the left-hand side of the operator. One other thing to point out, these are binary operators that produce a single result. So I guess what I'm going to do is I'm going to create a class, a test fixture, and as before we looked at creating test fixtures that had common setup. Binary operators, these kind of binary operators, all require a couple of parameters or operators or operands. So let's go ahead and create a class that represents that. So let's see. An RpnCalcualtor with 2 operands should. Okay. Now I'm going to do the boilerplate up front before, unlike before. So RpnCalcualtor okay, calculator equals new RpnCalcualtor. Great. And then I said it was with 2 operands. Let's go ahead and add calculator dot set accumulator new big decimal. I'll use the values I just did. So I said 3, 4, and then I also have to do an enter between the two. So calculator dot enter. Now one thing, you might think, well, don't I need to enter afterwards? Well, let's go back to the calculator for a second. So if I were to do 3, enter, 4 plus, I get 7. Great. What if I do 3, enter, 4, enter, plus? It duplicates, enter duplicates the current value in the accumulator. So I don't want to do an extra enter. I could, but that would be a different test. Alright, so I do not want an enter there. Add 2 numbers correctly. Okay. Now I'm going to put in a placeholder, even though I haven't got it there. Subtract. Great. So I guess calculator dot add. Now that method doesn't exist, so I'm going to create the method. I'll just create the method, leave it there for now, and then I should expect, so assert equals new big decimal. Actually, this is 3 plus 4, yeah, so new big decimal of 7, and I want that to be the accumulator. So calculator dot get accumulator. Alright, this test should fail. Okay, I expected 7, but it was 4, and 4 was the last thing I entered because add doesn't do anything. So let's go ahead and make this method do its work. Okay, so I said in my demonstration earlier with the calculator, the right-hand value of the operand was the most recently entered thing. So what if I do big decimal right-hand side equals values dot peak, values dot pop, big decimal left-hand side equals values dot peak. Now I need to big decimal result equals LHS dot add RHS, and then values dot replace top with result. All right, does that work? Excellent. So I get the right-hand value, I pop it so that I don't get the right-hand value twice. I get the top. I could do another pop here if I wanted to, but if I do that, that's going to override value. I don't. Since I'm I'd have to do a push here instead of a replace top. So I'm going to go ahead and just do it the way I had it. All right. Great. I got an add. Subtract is going to be pretty much the same. So let's go ahead and duplicate that. All right. So a couple things. First of all, this is subtract. And I'm going to hold that in place. And the result was -1. Okay, so let's create that method. Now, test will fail. Expected -1, but the result was 4 because it doesn't do anything. And now I'm going to duplicate this code. And instead of add, I'm going to subtract. Excellent. Now there's a lot of duplication here. That's fine. We'll get rid of the duplication. But before I get rid of the duplication, I want to add a little bit more. All right, so I want to also support factorial. Factorial is not a binary operator, so I'm not going to add it to this test class I just created. Newly created RpnCalcualtor. Okay. How's about we create a test that just does factorial, since it's a different beast. It takes in one parameter or one operand, and then it puts one back on. So I'll create a new test. Okay, so how's about now, the name of this test should hint at something. I'm just going to say that it should hint at something. I'm going to leave it like this for now. Eventually, we'll go back to that. But that's going to be a couple videos down the line before we get back to that. So, foreshadowing of what you don't know. I've got this, let's see, a newly created calculator. I'm getting sort of tired of duplicating this. Maybe I should create a base class. This is one case where I probably would allow duplication. Having a base class that just does this doesn't really add a lot of value to me. It might to you, and that's fine. If there were more setup, I might consider a common setup. But realistically, if the setup is very complex, it probably needs to be tested. I would maybe put it into a thing called an object mother, and then test the object mother for creation, and then use the object mother. But for right now, I'm just going to duplicate a little bit of code. So I'm going to allow for a little bit of violation of the drive principle. I might get bit, but for right now, I don't think I'm going to. So let's see, public void of 0 is 1. I'm going to put in my test cases first. All right. All right, so factorial of 0 is 1, of 5 is 120, and I'm just going to do this. I don't care about the other results, so this will be enough for now. So calculator.factorial. That method doesn't exist, so let's go ahead and add in that method. Okay, and then I want to assert equals now, unfortunately, this one's going to just pass, I think, because sure enough, an empty calculator. Oh, no, of course not, because, well, yeah, it's going to pass, but notice I said the factorial of 0 is 1, which it is, so let's change that to. There we go. Again, having a pair partner is a good idea. So that test fails. Easy enough to fix. Oops. Let's see. Is equal to, I'm putting in a little bit of the structure. Let's see, values.replace top result. Excellent. Now let's run the test. Cool, that works. So now let's go back to the test and put in this other one. So this is close, except that, let's see. First of all, I'm expecting and I want to do calculator dot push, or set, again, no, calculator dot set accumulator, and this time it's new big decimal of 5. Alright, now this is obviously going to fail because we've got a hard-coded result. Alright, I expected 120, but the result is 1 because I hard-coded the result. So now let's make the result work. Okay, let's see. I need to iterate or subtract. How's about this? I'm going to start with the result of 1, and I'm going to multiply it by the operand while the operand is greater than 1. So let's see. I'm probably going to get this wrong because I don't use big decimals very often. So big decimal operand is equal to values.peak. Okay. Now let's see. Operand dot remainder precision pow. Compare to. Okay, great. So while operand dot compare to and big decimal dot 1. Now, while this is greater than 0, result is equal to result dot multiply operand and operand is equal to operand dot minus subtract big decimal dot 1. Again, I don't know big decimals very well, so I'm sure there might be a better way, but I can get a better way after I get it working. I probably won't for the purpose of this video, but let's see if this is even close. What do I end up with? Okay, I'm actually surprised that that worked. It was quicker than I expected. So big decimals are a bit weird. I get the top value. Notice I don't remove it. I do the same thing here and replace top. Here, replace top. There's a little bit of similar handling. But now I've got factorial, subtract, and add. I've got some duplication. Notice I always get one value. In this case, I get 2 values. I do some work, and then I do some work, and then I replace the top. These two methods are exactly the same. Add and subtract are exactly the same. So that's just direct duplication, whereas factorial, not as the same. So let's go ahead and talk about fixing this, but I'm going to do that in the next video. For right now, all we've done is add a couple of operators. Add, subtract, and factorial. Next, what we're going to do in the next video is expose the commonality between add and subtract, and at the same time introduce a design pattern to handle adding operands in general. But to do that, I need to consider the API of the class. But again, that's the next video. Hope this has been another enjoyable video. Expect more in the near future.